All right, everybody, this is a big week for mathematics. We are working on the unit circle. So I came prepared. I brought the Flame of Knowledge. I am wearing my best hat, and it is time for math with Mr. Troy. Okay, admittedly, that was pretty silly, but here we go. Okay, so the last time we talked about a random scenario where we gave ourselves any old point in the coordinate plane, and we could decide just from its x coordinates and y coordinates what its sine, cosecant, cosine, cotangent, etc. were. We used r as our hypotenuse, and in that case, r was going to be the square root of x squared plus y squared due to our good friend Pythagoras. So, again, given some x and some y in a circle, the radius is going to be that r, that hypotenuse. Our sine is going to be our opposite over our hypotenuse, and our cosine is going to be our adjacent over our hypotenuse. Our tangent is going to be our opposite over our adjacent. Our cosecant is going to be the reciprocal. The secant is going to be the reciprocal of the cosine, and the cotangent is going to be the reciprocal of the tangent. This is assuming that r is anything. This works for any x coordinate and y coordinate that would be on the outside of any circle. So r would be the square root of x squared plus y squared, and we're always going to use r as a positive value for this, not greater than 1, greater than 0. To make things a lot simpler, we're going to put ourselves in what's called the unit circle, where our radius is going to be 1. So that gives us our first kind of trigonometric identity. X squared plus y squared equals 1 squared in the unit circle. Now, the reason we do this is because it allows us to say, well, the sine is y over 1. And the cosine is x over 1. The tangent is y over x. The cosecant is the reciprocal of the sine, so that's 1 over y. The secant is the reciprocal of the cosine, so that would be, of course, 1 over x. And the cotangent would be the reciprocal of the tangent, which is x over y. So if we can define our coordinates where we are in a circle with a radius of 1, we can easily figure out the sine just by knowing the y coordinate. We can easily figure out the cosine just by knowing the x coordinate. This is called the unit circle. The name comes from the idea of unit meaning 1, as in universe and, oh gosh, what was the other one? Unity. Cool. So this unit circle is a way for memorizing a bunch of trig facts really simply. It is made up of the following angles: 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then a whole bunch of families related to that. So for example, all of the blue rays here would be the 60-degree family. All of the red rays would be the 45-degree family. So we can go along and we can say 120 degrees, 135, and 150, and 180. All of measuring those out should hopefully be reviewed from geometry. Going along, we've got 210. So that's 30 degrees more than 180 degrees. That, remember, is called a reference angle. We've got then 225, 240, 270, 300, 315, 330, and 360. This beginning angle is both 0 degrees, and it's also coterminal with a full lap around the circle to be 360 degrees. Now, you may be saying to yourself, okay, so we labeled this circle with all of these measurements. What's the point? The point is that we're going to be able to figure out a whole bunch of different things for all of these angles. We'll be able to figure out what is the sine of 30 degrees. We'll be able to figure out what is the tangent of 210 degrees just by memorizing a couple of quick things. Now, to make this doubly useful, we're going to label everything in radians as well. So, recall that our radius is 1, and a circle has 2 pi radians in it. So we could start at 0 radians or go all the way around and be at 2 pi radians. Half of that would be pi radians. So to make sure we understand, this angle is either a straight angle of 180 degrees or a straight angle of pi radians. Now, what that pi radians means is 3.14 radians. So like the radius of the circle, 3.14 times. So we can go through and we can say if 180 degrees or a straight angle is pi, then half of pi, or pi over 2 radians, would be a right angle. And half of that, or pi over 4, would be a 45 degree angle, or half a right angle. That would make this red one 3 pi over 4. And if you think about it, we've got 1 pi over 4, 2 pi over 4, which would simplify to pi over 2, 3 pi over 4. This would be 4 pi over 4, which reduces to pi, 5 pi over 4. This would be 6 pi over 4. But of course, we wouldn't say 6 pi over 4. We would reduce that and we would say 3 pi over 2. And 7 pi over 4. And 8 pi over 4 would be 2 pi. So going around the unit circle, we can say, oh, 45 degrees in radians is pi over 4. If I can memorize that, I don't have to do the multiply by pi, divide by 180 thing, that conversion factor. I can do the same sort of thing with the other families. So 1/3 of 180 is 60. 1/3 of pi is pi over 3. Half of 60 is 30. So half of pi over 3 is pi over 6. And I can go along and counting the same sort of way, I can say 1 pi over 6, 2 pi over 6, 3 pi over 6. So think about that. 1 pi over 6 is pi over 6. 2 pi over 6 would be pi over 3. And 3 pi over 6 would be 1/2 of pi, or pi over 2. We've got 4 pi over 6, which would be 2 pi over 3. 5 pi over 6. And 6 pi over 6. 7 pi over 6. 8 pi over 6 would be 4 pi over 3. And you can always stop and you can say, okay, if 120 degrees was 2 pi over 3, then 240 degrees being double that, 4 pi over 3, that makes sense. Okay, so that would make this 5 pi over 3 and 11 pi over 6. It is totally crucial that you memorize all of those places. You need to get this under your fingernails. This needs to be absolutely second nature to you. Now, the point of doing this, of labeling it this way, is because these are our special angles. What do I mean by our special angles? Well, our special right triangle angles. So why did I pick 30 and 60 and 45? Because those show up in our special right triangles. So this 30-degree angle you see here, I'm going to think of that as a 30-degree special right triangle with a radius of 1, just like it shows on this slide here. So what you can kind of see here is the rationale behind this, that you can see where each one of those special right triangles would go inside this unit circle. Remember, it has a radius of 1. So all of these segments are 1, but this is a 30-degree angle, and the red one would have a 45-degree angle, and the blue one would have a 60-degree angle. Those are all things that I already know because I have those special right triangles memorized. It's important to realize as you're thinking of the unit circle that what the unit circle is a way to memorize a whole bunch of trig stuff, but that the actual circle you're looking at is just this little guy. Just the circle between -1 and +1 and -1 and +1, just on a coordinate grid. So, speaking of that coordinate grid, that can help us figure out all of this stuff. It can tie back in that, okay, it was y over 1 or x over 1 or y over x. Here's what I mean. In the unit circle, the center is the origin. And then every other coordinate is either related to 1 and 0 or a special right triangle number. So for example, the quadrantals are like this, labeled. But if I know that this is a special right triangle, 30 degrees, with a hypotenuse of 1, I know that this measurement has to be 1/2, and this length down here has to be √3/2. So my x coordinate here is √3/2, and my y coordinate is 1/2. So I'm going to go in and I'm going to fill in what all of those would be, the 30-degree family or the pi/6 family in each of the quadrants. So since those 30, 60, 90 right triangles don't change their size, all of our numbers are always the same, but they do change their orientation. So for example, on this one, the x coordinate is directed -√3/2 to the left, and the y coordinate is directed -1/2 down. So that's why our values are negative and negative. Okay, so the point of this is, if I said, hey, what is the sine of 30 degrees? You'd say, well, we learned earlier that the sine of an angle is the y coordinate. So the sine of 30 degrees would be 1/2. What's the sine of 210 degrees? That same y coordinate, except this time it's -1/2. It tells us all sorts of things about some angles that we see all of the time. Okay, now I'm going to go in and I'm going to fill in the 60-degree family, and you're going to tell me if you can notice the pattern between the 60-degree family and the 30-degree family. Okay, so see if you can notice the difference here. Right, good catch. The x-coordinate and the y-coordinate switch because that triangle goes from looking like this to looking like this. The orientation just switches. Okay, so now if I say, hey, what's the sine of pi/3? You say pi/3, well, that occurs right here. And I know from earlier that the sine is the y-coordinate, so that would have to be √3/2. Okay, I'm going to go through and I'm going to fill in the 45-degree family. Remember, in a 45-degree triangle, the legs are the same. That's why you see the x and the y coordinates having the same magnitude, even if maybe they're pointed in opposite directions. Okay, that is our unit circle. All you have to do tonight is, to the best of your ability, fill out a unit circle that you can get on the Google Classroom. There's something that's really important here. What's really important here is looking at this and saying to yourself, I understand some of this. It's really tempting to look at this and say, whoa, I have no idea what's going on. Don't do that. Stop, think back, rewatch the video, pause, fill in the notes, etc., and try and figure out how much you understand, and then try and come up with some good questions to ask if you've got them. All right, I'm going to give you a preview of the next slide, just so you can look at it, but you don't need to know how to do this yet. All right, cool, gang. Hang in there, okay? Keep learning. Make sure you're following through. Make sure you're doing all your homework. This time, all you've got to do for homework is fill out a unit circle. By the end of the 2 weeks, you should be able to do it in like 3 minutes. All right, I will see you later.